station, that is we are calling as a core station. IIT ISM Dhanbad is one of the eastern region having the core station under the National Center for Geodesy. Now I will give you just introduction about what is GNSS. In the yesterday's class I given about the GPS and GNSS. What is GPS and what is GNSS we will call the today's session. Just next. Now this actually we are calling as a constellation. The GPS constellation, all the satellites which are moving in a certain orbit. You see, this is one orbit. Some satellites are moving in it, and these are some satellites which are moving in it. Some satellites are moving in it. Now, if you want to determine your position on the ground, if you determine your position, let example, I am standing here. I want to know my position in terms of x, y, z. Now how I can define? Now this corner, let us take that corner is 0, 0. Now from there it is 2 meters x and 1.5 meter y. Now with respect to the something, I can define my positions. That is example, I am at the IIT ISM main gate. With reference to the Dhanbad railway station, the gate was defined as around 5 kilometers from the Dhanbad railway station. If you define any position on the earth surface, there will be some standard reference surface if you are doing the survey on a land. Now some positions, some areas, it is very difficult to do the survey, and it is a time consuming process to establish the local reference system. If that coordinate system I say that it is 0, 0, then only I can say my coordinate system. If that 0, 0 is not available, how I can define the position? To establish the reference system, it is a time consuming process. To overcome such kind of difficulties, a space-based constellation is established to get the coordinates of an object on the earth surface globally. Okay? Now for this purpose, a space-based constellation we are calling as a number of satellites which are established on the continuous contact with these satellites with the communication will determine your position on the earth surface. Okay? Now how we can do that and everything we will discuss. Now here if you see, there will be lot of constellations are there. One is Navic, generally we are calling it a GPS. The earliest only one constellation system is there, which is launched by the US. We are calling as a Navic, generally what we are calling as GPS. Now over the period of time, we are having the multiple constellations. Here, the Galileo, which is launched by the Russia, and we are having GLONASS, Russia, Galileo, European, and Beidou by China, and India, France, Japan. They are having their own regional constellations. These are the global constellations. These are the regional constellations. All the satellites which are moving around the earth surface. Now, from these satellites, your position on the ground is defined with certain principles. Okay. Now, these are here constellation means the number of satellites which are moving in a certain orbit. Now, an augmentation system, aircraft-based augmentation system that we are calling as ABAS, and space-based augmentation system we are calling as SBAS. Now, aircraft-based means there will be a certain communication systems which are in an aircraft that is moving in a certain region that will communicate the GPS signal to the ground-based receivers. And space-based augmentation systems, and again a similar separate satellite which is there that will communicate. This constellation is different, that satellite is different, that satellite will communicate the real-time error corrections to the ground-based receivers. Now, the ground-based augmentation systems are also available, and ground-based regional systems are also available to eliminate the correction on a direct receiver. What we are using, like mobile phones, otherwise the GPS receivers in a market. Next. If you go for if you understand the complete system of the GPS or GNSS, we are having a total 3 segments. One segment we are calling as a space segment, another segment we are calling as a control segment, another segment we are calling as a user segment. The space segment, as I explained in the earlier slide, there will be number of satellites which are moving in a specific orbit. For GPS, the constellation is different. For GLONASS, the constellation is different. The BIDO, the constellation is different. For various constellations, the number of satellites, some constellation is 30, some constellation is 24, some constellation is 27, some Japan constellation we are having 2. Like this, there will be in each constellation the number of satellites are different. Okay? Now the complete space segment, how many satellites are there in each constellation, and what is the satellite name, on which orbit it is moving, those are completely about the space segment. Now coming to the master segment. Now what is the work for a master segment? It contains the ground-based segment. It contains some master stations and some control stations and ground-based antennas. The master station will communicate. The master station will communicate the error in a particular satellite. Now, sir, what is the satellite? What is the error? Why? Because the satellite is moving in an atmosphere, above the atmosphere. There will be huge influence on the satellites. Maybe the satellite is moving fast, maybe the satellite is moving slow. At a particular period in a particular period it will complete one repeativity, but there is a delay. Otherwise, it complete fast. It will show error in the receiver. How it is, sir? What is the difficulty if it is complete fast or it is complete late? How it is affecting on the error? Here, on the principle, the receiver is working on the ground. That is, we are calling as in the morning 9 o'clock, one bus is dispatched from a bus stand. Otherwise, one train is departed from a Howrah, morning 6 o'clock. Now, what is the estimated time in Dhanbad? By 9 o'clock. Let us example, the train is delayed at Howrah by 7. Now, what is the estimated time at Dhanbad? 10 o'clock. Now, for each and every satellite, there will be some dispatch time. On the basis of that only, at next 1 hour, where is this position of the satellite? That is example I will tell you. At night 12 o'clock, the satellite is left this point. Now after 2 hours, the satellite is here. The position of the concerned satellite is determined on the basis of when this reference frame is crossed. Okay? Here, the example I given is at 12 o'clock, the satellite is crossed at this point. Now, this position at 2 hours is on the basis of this distance, how much it is traveled. That is the example. Here it is crossed at 12:30. Now, what is the position of this satellite? 2:30. But earlier it is 2. But now it is 2:30. Okay. This correction we should tell to the satellite you are 30 minutes late on particular date. That corrections are monitored on the ground segment with control stations, and with compile of all the control stations, those errors are communicated to the master control station, and master control station send the message to the concerned satellites. These all things, the data which we can use at the time of post processing. At the time of collection, we are simply collecting the data from number of satellites, but at the time of post processing, precise data, we use certain kind of. Why? Because what is the error in each satellite? For example, number 4, number 8, number 10, number 12, the satellite data we are communicating. But the number 4 satellite data is 20 minutes late. Example. But another satellite which is, there is no error. Now we can take that data instead of the error satellite, delay satellite. Now the purpose of the control station is, what are the satellites which are moving in an orbit, those satellite data is collected and the error is communicated to the master station, and the master station is communicated to the satellite. Okay? And next one is about the space segment. The purpose, the user segment, the purpose of the user segment is all about how the various receivers are receiving the signal from GNSS. If you see, there will be aircrafts and there will be navigation systems which is used by the ships, especially in case of the water, and the transportation facilities like last morning we discussed with the buses, vehicles. Now in future two-wheelers are also having the GPS. Okay. Now these are, if you see here on the bottom side, some are, this is called master station, and few stations which we are calling as controls. Okay. Next one. If you observe the figure, now there will be three circles A, B and C on the basis of trilateration. Instead of the triangulation, if anyone is not a civil engineer, they understand better what is triangulation and why it is trilateration. Okay. Now I will just give you an example. There is a triangle, right? The stations what we are calling is A, B and C. Now if you know the angle and if you know the length, if you know the angle and if you know the length with respect to the coordinate of A, we define the coordinate of B and we define the coordinate of C by length and corresponding angles. The method we are calling as a triangulation. And after proper adjustments in the angles and after proper adjustment of the baseline and everything, we define determine the coordinates of station B and C. But in case of, this is ground based technique. Because A and B, I have to measure the distance, and A and B, C angle, I have to measure the distance. Now this is one control station, this is another control station, this is another control station. On the ground, A, B and C, those are visible, and I can measure the length and I can measure the angle. But in the space, it is very difficult to connect the three satellites. Okay, to measure the angle, it is movable, not static. Now, what we are doing is, with respect to the length, station A, station B, and station C. With respect to the length between AB, length between the BC, length between the CA, that is measured. Satellite to satellite distance is measured between the, and again we connected a triangle. Those are not like this. These are like this. Okay. Now the trilateration, instead of the triangulation, the principle we are used, why measuring the coordinates of the unknown by knowing the length instead of the angles. Now the similar principle we have used especially in case of the GNSS, because now let us example, there is a receiver and there is a satellite. Now we are communicating with the receiver and find the length. Can I measure the length between the concerned satellite? Now on the basis of the principle, we continuously measure the distance from a constant distance, otherwise measure a distance from a particular satellite. These satellites are changing with time to time. But with the same particular satellite, how much time it is communicated and what is the distance. Okay? Now this principle, now if you see this principle, multi-trilateration, by knowing your distance from at least 3 points, by knowing their positions, you can determine your own position. Now let us examine with one particular satellite. One particular satellite, your position will be in a circle with a single satellite. Now coming to the another satellite, your position will be this one. And with respect to the another satellite, the position is the common area. Okay? Now if you see this one, it is looks like that. To minimize the triangle, now the time to maximize the receiver time. Okay? Maximize the receiver time, and instead of 5 minutes, you can go for the 10 minutes, you can go for the 15 minutes, you can go for the 30 minutes. Okay? Otherwise 1 hour. For the period of time, that will becomes now a precise point that let's say x now, y now, that is measured by completely removing the various errors in the receiver. Otherwise, the signal is propagated from the ionosphere. Okay? Now in this principle, it is about by knowing your distance from the at least 3 positions. With respect to the 3 satellites, I define my position. The fourth one, that is now if you see what I explained, now this is a satellite, the receiver which is propagating to the ionosphere. In the ionosphere also there is a delay after my signal is there. That delay is also affecting on your receiver position. Okay, for an example, this is a light. If I am standing here, I am directly receiving the signal. There is an example, there is an obstacle. That is ionosphere. Okay, ionosphere, if that is also affects the direct delay of the signal. The signal is delayed means the distance is increasing. The distance is increasing, that will implicate on the error. And another one is, suppose I am standing in a big building. For example, this building, I am standing like this. Okay. Instead of receiving the direct signal, what happened? The signal is incident of the building and I am receiving the reflected signal. That is also increasing the distance. Okay. Instead of the direct distance, you are measured the indirect distance, that we are calling it pseudo. Yes, so those are indirectly increasing the error in your receiver. Okay. Now, assuming straight paths of radio frequency signals, Earth ionosphere actually disrupt with the path. In this case, you will actually bend the path which is from a passing from the ionosphere signal from satellite. Augmentation correct for that bit using a dual frequency measurements currently not possible direct in the aircraft, and some signals are by certain satellites by keeping the certain altitude for continuous observation of the ionosphere reliability, we can apply those corrections to the concerned receiver to correct the base or receiver observation. Next. Now the satellite based augmentation, what I am discussing about. If you see, there is a receiver, there is an example, this is a receiver. Aircraft is having the GIS mounted module is there. This is the receiver. Now this receives the signals from the satellite, direct signal from the satellite, and the ground based earth observation which communicates the correction to the concerned as well. There is one more satellite. Now it will communicate the error to the concerned receiver. It means from the GNSS I am receiving the signal. Whatever the error is there, that is received from the parallelly, that is received from the concerned another satellite. Now my position, that is x comma y comma z. Now let an example, there is a 1 meter error is there. Now automatically whatever the x comma y comma z is there, I am doing that error. X minus 1, y minus 1 and z minus something. Now the direct live precise location. Otherwise the error that will be getting after completion of one rotation. एक ट्रेन हावड़ा से डिस्पैच हुआ है, रांची रीच हुआ है 12 बजे. रीच होने के बाद ही पता चलेगा व्हाट इज द डिले. एक सैटेलाइट कंप्लीट होने के बाद ही पता चलेगा ना. So whatever the reading what you are observed, the error will be appeared after 24 hours. ठीक है? Now this satellite will communicate the error to the concerned receiver. Now the receiver will apply that error and directly make the precise. Okay. Now some of the example where we can impose these things in a real manner. Another example, we are having the aircrafts. Aircrafts are mounted with the GPS and GNSS modules. Those are landing. Okay. Now if you know the runway. Runway is there. Runway is also having the x comma y comma z. Can I measure the x comma y comma z of the runway? Runway. Now the aircraft is also having the x comma y comma z. Now this is the runway. If suppose I want a smooth landing, मुझे smooth landing चाहिए. Now can I find out the distance between 2 points? Can I find out the distance between 2 points if I know the x comma y comma z? X comma y comma z. Okay. Now if it is in centimeters, then only I can land. If it is in meters, I can again go for the smooth. In centimeters, then I can. But this is option. Example, the correction which is supplied, that is option. The error is in meters. Correction आपको पता नहीं है. The error is in meters. Now from the meters, this jump. There is example, the correction is already, the correction I know. I apply the correction. Instead of the meters, it is in centimeters. Now I can go for this one. Okay? Now that system we are calling as a bus. Satellite. Okay? Now the India is planning to implement as bus the various user segments, aircraft, vehicles. Okay, the national highways. How the national highway NHAA knows you are on a national highway? FASTag is removed na next coming days. How they know your vehicle is on the national highway? Suppose my vehicle is having GPS. How national highway NHAA authority know I am on the national highway? Suppose my vehicle is running on state highway. How they know my vehicle is on state highway or national highway? Otherwise, how my vehicle knows I am on national highway? Now, what are the national highways there? National highway edges are there, na? The national highway edge is completely geotagged. Now, my vehicle is in the range of that geotag, na? Automatically it will detect, it will say that you are on national highway. Complete road network is there. Can we digitize the complete road network in GIS? Okay. Now it is any vehicle that particular range, edges of the both sides of the road. Now automatically it will detect and it will say that you are on the national highway at particular time. My vehicle is having GPS. Okay. Now that is an example. If I am coming into the geotagged area. Okay. Now my vehicle is here. Will not detect. Now I come inside. It is geotagged area of both the lines, both the edges of the road. Now it will detect and it will 0 0. If I travel 2 kilometers, if I travel 5 kilometers, now it will automatically detect. So why? For 5 kilometers, for 10 kilometers, 10 kilometers. जितना मैंने ट्रैवल किया है उतना अमाउंट detect. बट अगले क्या है? टोल गेट के पास जाना है तभी by using the FASTag they detected and they cut the particular. Now the SPAS will give you a proper correction to the receiver to get a precise locations in a line. Next. Now satellite sends orbit and plot information. GIS satellite includes almanac and numeric data into the signals they transmit. It means that the kind of information which is transferred to the ground-based receivers, that is called what is the satellite number and what is the clock bias. Okay. And what the clock bias, the information is like at what time it is in a particular position, at what time it is communicated with my receiver. That is the communication between these two, from the receiver to the concerned satellite. Next. And back. Now, numeric data are very precise orbit and clock correction for each particular GPS satellite. It means it will produce a clock correction in each particular satellite. That helps us to determine the precise position of the receiver. If I know the correction, then only I can apply what is the correction in my receiver. I will remove that correction, I will get the precise position. Next. Now this will give you the similar example what I explained in the previous slide. If you see, this is one satellite, this is another satellite, one satellite, another satellite. Now this is the region. Third satellite, now this is the common portion. Now over the period of time, the location, the intersection portion is slightly going to the minimum and the average is also in a centimeter level. Now this particular flowchart explains the figure. It is explain how the strategy changes in the GPS receiver. You see, there is a small handheld GPS receivers are there and GNSS receivers are also there. Those are generally used for recreational and for landing system. want to collect the whole data, you want to collect the control station data, you want to collect the expensive, it is very low cost, around 8,000 to 3,000 you will get it for a GPS. GNSS, in a meter level of accuracy, you will get handheld GNSS around 1 lakh and 1.5 lakhs. In case of the kinematic, that is expensive, moderate to complex, short operation, position can be rapid, post processing. And in case of the static, expensive, high complexity, long operation is required, long and complex and post processing. The kinematic, you can get, we are calling it the real time kinematic. It means we will communicate with the base and parallelly remove the error in a concern base. Next, concern row. Now first we will discuss about the static GNSS. It means that it is not movable. It is static for a certain period of time to continuously collect the GPS data. Continuously collect the GPS data means in reality you assume it is continuous in contact with the some satellites. In contact with some satellite means I am measuring a continuous distance. Suppose if you are satellites, okay, if I make a line with the concerned person, each person, I am the receiver, I am continuously connecting with you. If I draw a line, if someone is went outside, now that line will be erased. Okay, and someone is moving somewhere else, that line is erased. But over the period of time, over 4 hours, or 5 hours, or 6 hours, the persons, at least 4, 5, 6 satellites, they are continuously in contact with the receiver. Okay, that continuously will after static. Okay, now once we receive the data, now we come to the lab with certain base, do the post processing and eliminate the error in each and every model. Okay, so you see a long duration operation over a well-mounted marks, permanent stations are fixed using the deep anchors and run continuously. Campaign stations are revisited frequently and occupied for 8 to 48 hours. Now these are some of the static GNSS receivers. Some those are called freely available and some are not providing the data. And GNSS, that is global navigation satellite system. The definition of the GNSS is global navigation satellite system. And next one is, what is the possible with static GNSS products? Spatial position within a few millimeters, what we are getting, requires intentional and high precise positioning. Thus can back very small changes also. Even if you observe that millimeter level of accuracy means even a small millimeter also, almost 5 to 10 millimeter level also we can detect. A small millimeter level means subsurface monitoring. Otherwise, what we can say, erosions, earthquake displacements. Those things can be done by using the static GNSS. Next, so next one, another one is about the kinematic GNSS. Next, now see, the static GNSS we are having only one receiver, but in case of the kinematic we are having the 2 receivers that will communicate with the base. Now the base is continuously collecting the data and the rover is continuously collecting the data. The base, we can't move the base for a certain time period. We move the rover for next every 10 meters or every 10 meters to various places. Now the base will communicate the error with the rover. What are the corrections? Yes, pass we discussed in the, it will communicate, but it is a satellite. But it is a ground based. Now it will communicate the error to the rover with a radio communication. There is a communication between these two with the radio. This radio communication is around 5 to 10 kilometers range. The error let us example, the connection between the base and rover is down. What happened again? The rover is also working as a receiver, but the error is not communicated. What are the readings, what are the observations we are getting in a receiver requires some corrections. If the base connection is removed, base connection is not, the radio signal is not properly working, that connection is not communicated properly. Now the horizontal position and vertical position is the error is next. Now this is the some of the methodology how the kinematic GNSS is working with respect to the base. What we are generally calling as a RT, real time kinematic. Now this is about how to download the this one. Remember this Remix file. Any kind of GPS instrument you use, Rebel, Leica, Spectrum, any kind of instrument you are using for the GPS signal or GNSS signal, you first of all export that data into Linux file. Any software, generally Timbol and some software, they are going for, they are accepting their own data, that is T0. So the actual file, you may export the Linux file, what you are working is a Linux file. It will support all the software for the post processing of the data. Now upload the Linux file to the open source software. Upload the Linux file to some of the open source software, that is Opus, otherwise Gamut. To get the corrections for a proper base station. The working principle is like we are having a base. We are having a base station. This is a set of the base station. Now the base from the base station, first of all you continuously receive the data and you correct the base station. For an example, today I get the base station 8. What are the 8 hours, 10 hours I can take? 8 hours is continuously in contact with some satellites. You remove the error in this particular base station with some other base stations who are permanently kept on the ground and collecting the GPS reading over the period of months, years, days. First what we do is, the base, you connect the base observation with some IGS stations, with some core stations. It means now this is the base station, some of the IGS stations are there, you can connect these things and determine the post-processing coordinates of the base. That we are calling as a post-processing. Error is removed. Now after the base coordinate will get precise base coordinates will get. Now again with these coordinates, the next day you keep the base, what we are calling as a setup. What we are calling is setup. Set up the base at the same position what yesterday you kept and connect the rover with the base with the radio, and you can take the number of coordinates. Okay, now finally it is like finally it is like this. With the proper base, whatever the correction in the rover has removed, the correction is communicated to the rover and the precise coordinate of the rover is done in the real time. We are calling it a RT. Real time. With this principle, डिटेक्ट मिलीमीटर लेवल में हम लोग डिटेक्ट कर लिया, वो मीटर लेवल तक पहुंचने में जो टाइम लगेगा, मिलीमीटर लेवल में डिटेक्ट कर दिया तो इमीडिएटली टू सेंड एन अलार्म, स्पेशली इन केस ऑफ स्लोप स्टेबिलिटी, dumps, vertical zones, or hilly region. There is any millimeter level of observation in terms of the deformation observed, immediately inform to the concerned team for an early warning. Now tracking of objects of the interest and landslide slips, indicating volcanic area domain and the sum of the changes woman cannot perception. In such cases, the millimeter level of deformation is using GNSS. Next. And this is about the tracking position using the recreational system. You see, I want to know the area of the particular field. Now I can collect the information about these points. Area. By using we will calculate example. This is one of the mine. Then I can cover the boundary of the mine and find the actual true area and export it to the table for overlapping on the satellite images. And one more thing about the kinematic, we have prepared the GIS distribution models also, and surface generations are also. We are created in the GIS by taking the GNSS data as input, because we have external bidirectional data in GNSS. And some of the change detection, earlier how it is, now how it is. You see the movement of certain control stations, especially in case of the hilly regions, especially in case of landslide zones, especially in case of substance monitoring, in case of slope stability areas, we construct some control stations. Those control stations are observed, monitored, either maybe in the monthly wise, maybe in the days wise, as per the observation, as per the week wise, they are observing what is the movement of the control station in a hazard prone region. So this is all about how the GNSS works, what is the base, what is the rover, and what is the what kind of communication with the receiver, satellite transmission, how the error is measured, what are the major observations we can observe from the satellite orbit, and what are the corrections, what kind of corrections are there, what is the purpose of post processing, why post processing is required, what is static GNSS survey, what is kinematic GNSS survey, what is the error, how at what part we can go for the precise positioning in case of static, and what part we can go for the precise positioning in a kinematic. This is all about the GNSS survey. Is there any doubt regarding the GNSS? Let's go to the document. Why? Because the next go to the field and see how we can set up the base and how we can collect the data with rover. As I said that base to the rover there is a connection. Okay? That is the example. Base will continuously collect the data, rover is continuously collect the data. That is we are calling it static. And once we remove the error in the base, we can remove the error in rover also. It is static mode. If it is a kinematic, there will be communication between these two. Okay?
सर सैटेलाइट वाले सिस्टम में तो एरर मुझे समझ में आ गया कि जो टाइम डिले होता है उसमें असर रहता है। फिर ये जो हम खुद का बेस जो सेटअप करेंगे उसमें किस तरह का एरर आ सकता है? जब हम सैटेलाइट की बात कर रहे हैं, सैटेलाइट में जो उसके जो रिवॉल्यूशन में जो चेंजेस आ रहा है उसकी वजह से मेरा एरर आ रहा है। बट जब DGPS में हम लोग ये कर रहे हैं, जो अपना सेटअप लगा के जो बेस स्टेशन बना रहे हैं, उसमें किस तरह का एरर आ सकता है
DGPS में?
हाँ, मतलब सर जो ये रोवर वाला सिस्टम जो भी आप बता रहे हैं,
आप DGPS having one base and one receiver,
हाँ
both let us treat both the receivers, ठीक है?
हाँ,
इसमें भी एरर होगा, इसमें भी एरर होगा,
अच्छा,
but finally in the particular satellite which is moving in a particular orbit having some error, पहले उसको उसमें उसका अंदर कितना एरर है, पहले we are first of all we are find out, वो एरर कब आएगा? After one complete resolution, एक दिन का बाद हमको एरर आएगा, then the error is communicated to the base, ठीक है? We are applied to the base, not communicated, we apply that error to the base, पहले base को error remove करें, then with respect to the base, the rover is communicated, then we remove the error in the rover in a post process, but especially in the live में क्या होगा? आपका गाड़ी चल रहा है, उसका अंदर GPS है, सपोज मान के चलिए आपका कनेक्शन पता नहीं है, आपका कनेक्शन पता नहीं है, बट एग्जैक्ट पोजीशन मीटर में वेरिएंट होगा, मीटर डिफरेंस में होगा। सपोज आप नेशनल हाईवे के अंदर नहीं है, नेशनल हाईवे के बाहर में रोड है, उस रोड में जा गाड़ी आपका GPS जो है एरर का हिसाब से नेशनल हाईवे में दिखा रहा है, तो क्या होगा? अब पेमेंट करना पड़ेगा। You may claim that you are claiming that I am not running my vehicle in the national highway, but it is not showing the proper centimeter millimeter level of accuracy. It is showing as a net level of accuracy. but national highway का रोड में देखा, इससे क्या होगा? आपका ऑटोमेटिकली जो है इसको एलिमिनेट करने के लिए क्या है, there will be S-class system which will communicate the direct error to the receiver and get a precise position in millimeters. तो फिर आप क्लेम नहीं कर सकते, आपका रिसीवर मिलीमीटर लेवल पे एरर दे रहा है, ठीक है? समझ में आ गई? ठीक, तो आप चाय वगैरह पी लीजिएगा, फिर हम लोग फील्ड में चलेंगे। तो फील्ड में जो स्टेशन इज देयर, परमानेंट कोर स्टेशन इज देयर, और वहाँ पे हम लोग बेस एंड रोवर को सेटअप करेंगे। तो then we will see how to set up the job and how to create the file in a rover or in a base and how to collect the data, ठीक है? हम लोग जो क्लॉक नेचुरली यूज कर रहे हैं वो GPS टाइम अलग है, हमारा टाइम अलग है, इस दोनों को कोरिलेट कर सकते हैं, ठीक है? और क्वेश्चन दैट इज डिले, टेलीकास्ट डिले, ठीक है? तो receiver which is having 450 megahertz radio and having internal battery and wireless communication in terms of Bluetooth, in terms of the SIM card is also there, and having an internal we can say memory and parallel with a SIM card. Okay. Now we will see one upon one. So this is the front face of the receiver. Now if you see the first one that is called indicator in terms of the radio, there will be 4 indicators are there. The first one, this one is about the radio. The next one is about the download, data downloading. This one, if you see the symbol also, actually those are blinking once we switch on. Okay? And this one is about the number of satellites, whether it is connected with the satellites or not. And this one is about the Wi-Fi communication with the monitor. Okay? And parallelly the power in, power off button. Now this is the front face of the receiver. Once you switch on the power button, all these what you can say lights are blinking on a receiver. And again we are having the radio communication, SMA radio antenna connector. So this is called radio antenna connector. As we discussed, connecting with the base. And again parallel the quick release adapter. Can just press button and remove the receiver from a antenna. And we are having a SIM card slot. And we are having battery component. This is the battery. Battery, and there will be two ports. We can connect with the serial communication cable. We can connect with USB cable. Just in the next figure, if you see those two, this is a serial connected port. This is a USB port. The quick adapter joiner that is connected with this one. Now you simply ventilate and lock it. Now these are the two rechargeable batteries. Almost it will give you 4 hours backup. Now once the 4 hours are there, then you can change it. And we can connect the external battery also. Okay, especially in case of the base, it is continuously already we discussed in the PPT. It should be 8 to 48 hours. So this battery capacity is only 4 hours. Now we require some other external battery. We are going for precise batteries which will give you almost 10 hours, 12 hours, 14 hours backup. These are the rechargeable batteries. Once the work is over, you can go for the recharge and you can use the next one. It is giving almost 6 hours, but for an RTM mode, such cases, it is works 4 to 5 hours. Now, how we can insert the battery? Now there is a button. This will be the button. Now you can just press the button in the one direction. The battery will be pulled down. Okay? Once you can insert the battery and release the button. This one. This is the lock. If you press this one, the battery will pull down. Okay? Now once you pull the battery, release the lock. Lock. Right in this position. This will give you the adapter, this one. This portion is this one. And this will give you the what you can say adapter. Base measurement level. So you can measure the height of the antenna from the surface. Sometimes the antenna is here. Sometimes the antenna is here. Sometimes the antenna is here. What is the height from the station? We are not keeping the antenna on the bottom. On the pole we are keeping our receiver. At what height we are keeping the receiver? At what level? For the leveling purpose, this extension is given up to measure the tape from a ground. From where you kept your GNSS. Next. This one. You see? Whether you are measuring to the bottom of the antenna, this is bottom. You see here, bottom of the antenna. And this one is about bottom of the quick release. This one is about the level of antenna extension. In the field book, you should note down up to what you are measured the height. You should enter in the initial setup. Then only, why? Because antenna is here. If someone is asking, what is your height? My height is 5 feet 6 inches. But where is 0? 0 may be floor, 0 may be this one. Standing on the roof, the 0 is the roof. You have to define that. But the distance is measured from here to foot only. Okay, here the signal is received here. But you want the coordinate on the bottom. What is the purpose of the height measurement is the signal is received here. But you require the coordinates on the ground. Now, Z pata hai. Remove this one. Remove this height. You will get the coordinates. And this is the bag setup where all the necessary cables and everything to be kept safely to carry the instrument from one place to the another place. This is about the various parts. Now how to connect the various parts and what is the receiver, what is the arm, and what kind of cables are required, and how to set up a job. step by step procedure. Okay, now this is about the radio link connectivity. Parallelly, once you have everything, you can go from the start. And the first one is about the base started. First of all, you should start the base, and next one you start the rover. And which mode you want to start, whether it is static mode, RTK mode, you have to choose it. Then you can go for the storage of coordinates. You see the left hand side, store the entered coordinates. Like I said that base initial coordinate to be entered. Next one, you see, this is called the base coordinate. This is called the base coordinate. So today, if you set up a base, okay? Now I given the base 1, base 2, base 3, like this, whatever name you want. So this is the base. Once the finally after 10 hours, after 5 hours, after 6 hours, whenever you want to keep your base station, finally you stop and store that one. Now this file is like this. Now this file is exported into various formats. Maybe you can export into Linux format. You can export that one into shapefile. You can export Excel file for post processing of the data. Now these are the various steps where you can eliminate. You see the comma elimination job. Normally here, comma means that will be exported in Excel format. Okay, CSV format. Now these are the manual we are prepared for the post processing of the base and row. Okay. And you can, final thing is you can export this data into Google form, otherwise Excel format. If you want to represent in a table, you can use the Excel format. Otherwise, you want to show the same data to your officer or senior manager or someone, you can directly export the Google Maps. KMZ file. Now you open this data, the Google Map directly it will show like a points, various points. From base से मैंने line खींचा था ना, that it looks like there is the base and where the points are connected in a anegraph. Because on the background satellite image is visible Google Map and your point location is also